So welcome to the studio here in Paris, where I'm joined by Julian and Montgomery, and we're going to be talking about an innovative power project in Afghanistan. Gentlemen, thanks for joining me today. You've just completed a major project in Afghanistan. I wondered if, first of all, you could tell us a bit about that project.
Sure. So Bayat Power is the largest private IPP in Afghanistan. So we're very pleased to put into commercial operation on Sunday, in fact, the first gas-fired turbine in more than 40 years in the country. It's the first phase of a three-phase project that will ultimately deliver 200 megawatts to electrifying Afghanistan.
Okay. So that was the first phase. So what are the next two to get to that final end game?
So in the first phase, we utilized Siemens' fast power solution, mobile technology, to get electrons moving as quickly as we could. Second phase will involve placement of a second turbine on the same site in northern Afghanistan, and then we'll build out and scale out a land-mounted solution in the months ahead.
Okay. And with this project now complete, what's next more broadly for Afghanistan? What are its real challenges? I guess there's quite a few, but is it fuel supply? Is it grid?
Sure. Afghanistan's single biggest challenge actually is just electricity supply. So it's a nation that imports almost 90% of its power. So natural gas is the base fuel for the future of that country. And this is the first project to show the world that it can be done and that private investment with advanced technology like the Siemens engine can make it work. So I think the biggest challenge is just building out more projects like ours. And the gas supply is there. Security, of course, is usually the single biggest challenge in Afghanistan.
And you mentioned the Siemens technology. What was it about that technology that you've used in this project that made it most appropriate for the project?
Yeah, so this project is based on the Siemens SGT A45 mobile turbine. And the turbine comes with certain features that makes this project possible. Number one, it is a mobile asset, so you can think about a modular design. It's a gas turbine module, a generator module, and a power control module, each sitting on a trailer, so it's highly transportable. It actually can go into the Antonov airplane to be flown into Afghanistan directly. And the modular design also makes it possible to be installed and commissioned rather quickly, because each of the units that come out of our manufacturing slot get tested based on that specification as it is built in Afghanistan, built for Afghanistan. And that means that the project can generate revenue earlier, and you minimize the site work requirements to make it possible.
And presumably, the benefits of that technology can be rolled out in many other countries that have the same issues as Afghanistan.
Absolutely. So the core of the gas turbine module is based on our derivative Rolls-Royce Trent engine, so with many million hours of operations, based on what we have seen in the air industry, but also being employed as aeroderivative turbines for peaker plants, etc. So it has power output up to 44 megawatts and 40.5% efficiency. So that makes it a very valuable asset indeed. At the same time, you can ramp it up from cold to full load in only 5 minutes. It can be restarted at any time, and it can actually hold up to that high power levels at 40 degrees Celsius, which makes it a good asset to be employed in hot ambient conditions. And beside that, we're employing it here for a fast power application in a country that's in need for electricity. But at the same time, that asset is also very valuable when you think about, we want to enable the baseload renewables assets, and we want to make sure that we have grid stability and grid resilience. So this asset can really be used also to stabilize the grid. And it can also be used, to quickly expand on electrification, make sure that we can retire all coal assets and make sure that we can get power where it's needed the most and really substitute less efficient technology.
And in that context, we're on the cusp of 2020, which is quite a seminal year for all sorts of landmark reasons. Going forward, what are the things that you are most excited about, that you anticipate coming in the next year for regions like Afghanistan?
For regions like Afghanistan, I do think that we have a possibility to build out on that technology and similar technologies. So there are solutions where we can couple gas turbines with batteries to create hybrid assets, we call it. So this makes it possible to, have peaking assets that are very quickly, you can ramp up very quickly, but also for a longer period of time. Another opportunity is that this turbine can burn hydrogen up to 100%. that makes it very interesting in the discussions we have on the energy transformation piece. And actually, all of our Siemens derivative engines can burn up to 100% hydrogen already.
Montgomery, for you, what's the coming year going to hold for Afghanistan?
Sure. So twofold, continue to scale out more electrons to the grids. And Afghanistan is undergoing a really interesting grid digitalization and transformation project. So we have some involvement in visualization applications with Siemens and some other work to help sort of modernize as more generation comes on board domestically, let the utility better manage that.
Gentlemen, it's a great story. Thanks for sharing it with us.
Thank you.
And don't forget to check out our YouTube channel for more great content. That's all for now.